Okay, hopefully you've already watched the video regarding redox reactions, but I'm going to go over it again. Okay, so grab an ion chart. We need that. And we're going to assign oxidation numbers to all our elements. Okay, so in this first one, we see H2O. So right here, hydrogen. What's the charge on your hydrogen? +1. So I'm going to put my +1 there. And then we've got oxygen. What's the charge on your oxygen? -2. Put my charge there. Okay, on the other side of the reaction, we have hydrogen gas plus oxygen gas. Now let's recall, if these elements are alone, what is their charge? 0. Okay, so then let's go down here and answer our questions. The initial oxidation number for hydrogen is +1. The initial oxidation number for oxygen is -2. All right, on the other side of the arrow, on the product side, what's our charge? 0 and 0. Okay, are electrons gained or lost? Now remember, we cannot gain or lose protons. We can only gain and lose electrons. And protons are always equal to electrons. Remember that? If we have a charge, this means we either have more protons or more electrons. For the hydrogen, here this would mean I have one more proton than I do electron, and here this means I have 2 more electrons than I do protons. Okay, so on this +1, and then after the reaction it's 0. Why? Because now my protons equal my electrons. What happened? Did I gain or lose an electron? Well, I had to gain an electron. Why? Because if this was an extra proton, I gained an electron, so now protons equal electrons again. So let's remember our little saying, Leo the lion goes grr. Loss of electrons, oxidation. Gain of electrons, reduction. So if I gained an electron, this was reduced. But here on the oxygen, I started out, I had 2 more electrons than I did protons. So what happened? I went to 0. Where did those electrons go? Well, they were lost during bonding. So that means loss of electrons, oxidation. So these were oxidized. Okay, I can only gain and lose electrons. Let's look at the next one. Okay, same thing. We need to assign charges. Sodium doesn't have a charge. He's all alone. Mr. Sodium's by himself, plus this Miss Chlorine here, she's all alone. No charge. All right, so let's go to our initial oxidation numbers. No charges. Elements that are alone don't have a charge. When are we charged up? When we're in a relationship. Okay, so now we've got sodium and chlorine are in a relationship. So sodium has a charge of +1. Chlorine has a charge of -1. Let's put that here. After the reaction, what happened to my sodium? It was charged up. My chlorine is charged up. Okay, what does this mean here? This means protons equal electrons in this box. On the other side of the equation, though, protons do not equal electrons. All right, what happened? This is I have 1 more proton than I do electron. What happened? Well, I must have lost an electron. Loss of electrons equal oxidation. And in this scenario, I have an extra electron. So if I gained an electron, it was reduced. All right, let's go down here. Let's look at C. Okay, again, assign your oxidation numbers from your ion chart. Okay, sodium's always +1. Sulfur is always -2. Hydrogen is a +1. And chlorine is a -1. On the other side, again, we don't have any single elements, so these are all charged up because they're all in relationships. So assign all your oxidation numbers, okay, from your ion chart. All right, let's fill this in. Before the reaction, what do we have? Sodium's a +1, sulfur's -2, hydrogen's +1, chlorine's -1. On the product side, what happened? We still have +1 sodium, -1 chlorine, +1 hydrogen, -2 sulfur. All right, so notice all the oxidation numbers on the reactant side and on the product side are the same. Okay, because this is what? This is a double replacement reaction. We just had people switch places, right? So no electrons were gained or lost during bonding. So we say this is not redox. Nobody was oxidized. Nobody was reduced. Okay? So keep going. You can work on the next one by yourself and see if you can do the other ones. If you have a question, let me know.